In the last section, we wrote a small file to make some HTTP requests for us, then ran it and saw that it took about 240 milliseconds to make a single request over to Google. We're now going to add in some more requests to this file, and when we do so, we're going to see some evidence that some of the functions in the node standard library don't seem to use the same kind of thread pool that our hashing function did previously. So inside my async function, back over here, I don't really want to copy paste this entire code block down like 6 times. So I'm going to wrap this request inside of a little helper function that I'm going to call simply doRequest, like so. So now rather than doing a whole bunch of copy pasting, at the bottom of the file, I will instead call doRequest a couple times in a row. And maybe that's good like so. Okay, so let's save this file, and now we're going to go run this file again at our terminal. So back over at the terminal, I'll again do node async.js. And now we see some very interesting behavior. Notice how it appears that all 6 calls appear to be completed at the same exact time. This is distinctly different behavior than what we saw previously with our thread pool. So remember, by default, the thread pool has 4 threads, which means only 4 tasks can be processed at a time. But in this case, we had 6 tasks all completed simultaneously. So what's up? What's going on here? Well, let's take a look at a quick diagram. Now, let me move this thing around. There we go. All right, much better. So what we're seeing here is more evidence of libuv in play, but it's not related to our thread pool. So just as the node standard library has some functions that make use of libuv's thread pool, it also has some functions that make use of code that is built into the underlying operating system through libuv. So in this case, libuv sees that we are attempting to make an HTTP request. Neither libuv nor node has any code to handle all of the super low-level operations that are involved with a network request. Instead, libuv delegates the request making to the underlying operating system. So it's actually our operating system that does the real HTTP request. Libuv is used to issue the request, and then it just waits on the operating system to emit a signal that some response has come back to the request. So because libuv is delegating the work done to the operating system itself decides whether to make a new thread or not, or just generally how to handle the entire process of making the request. So because the operating system is making the request, there is no blocking of our JavaScript code inside of our event loop or anything else inside of our application. Everything or all the work is being done by the operating system itself, and we're not touching the thread pool at all in this case. Okay, so let's pause right here, and we're going to continue the next section and talk about how this relates back to our event loop in the next video.